Hey everyone, thanks for coming back, checking out my video for section 1.3 in my calculus class, evaluating limits analytically by just doing direct substitution. It's going to be a pretty quick video, and I've got 4 examples here, but as you'll see here while we're doing the problem, I have the property here, direct substitution. We've done the numerical method by making an XY table. We've done a graphical method by looking at the graph. Now we just want to do an analytical method by direct substitution. And really all we are going to do is when we are plugging in, when we are plugging in our C value right here, we're going to wind up, by taking this value and plugging it in for X. And that's pretty much it. This is the way you want to do pretty much every limit. You want to try direct substitution first. So let's look at 2 basic ones right here. We have the limit as x approaches 2, 3x squared minus 2x plus 5. I am going to take simply this 2 right here and plug it in wherever I see an x, and I'll get my y value. So I'll have 3 times 2 squared minus 2 times 2 plus 5, so we'll have right here, we'll have 12 minus 4 plus 5, and we will wind up with a limit of 13. So direct substitution, as you can see, pretty quick. Didn't have to make an XY table, didn't have to look at a graph. Let's look at another one right here. The limit as x approaches 3. We're going to take this 3 and we're going to plug it in right here and see if we get an answer. We'll have the square root of 2 times 3 and then plus 3. So as you can see here, 6 plus 3, we'll have the square root of 9, and therefore as we approach 3, we'll see that we will actually have a limit of 3 for our answer here. Now that's just the straight direct substitution. Let's look at 2 more that require just a little bit more algebra first. So if we look at these 2 right here, we're going to try to plug in negative 2. And when we do that, we're going to wind up with 4 minus 4 over negative 2 plus 2. We wind up with 0 over 0. Now in calculus, this is known as an indeterminate form. And we don't like this. So direct substitution didn't work. We got an indeterminate form. We got 0 over 0. So what we want to do is, well, like I said here, let's do a little algebra first. So if we do a little algebra first here, I know that x squared minus 4 factors to x plus 2 and x minus 2. Well, algebraically, I know now that the x plus 2's can cancel out. So this actually simplifies to just having the limit as x approaches negative 2. Instead of this big equation, now I just got x minus 2. And now, direct substitution-wise, I can plug in negative 2 right here. And when I do that, I wind up with negative 2 minus 2. I get a limit of negative 4. So we did a little bit of factoring right there. So again, it's just some basic algebra. Take a look at this one. We want to put in 0. Well, again, we're going to wind up with that indeterminate form of 0 over 0. So can we do some algebra? Well, we sure can. We can factor out an x from the top, and we're left with x minus 1. Put that all over x. And as you can see here now, by doing that, the x's cancel. So the limit of x squared minus x over x can actually simplify, and we get a new limit. So we'll get the limit as x approaches 0 of just x minus 1. And if we plug in 0 now, we wind up with negative 1. So there's 4 quick examples of just doing direct substitution. So at the beginning part of when you're doing limits, this is for my calculus class section 1.3. So thanks for tuning in. If you have any questions or comments, just put them below.